Welcome back to Saxon Math. This is Course 1, Lesson 26, using manipulatives to reduce fractions, adding and subtracting mixed numbers. It's a new concept. You can use fraction manipulatives to model these fractions: 4/8, 3/6, 2/4, 1/2. You see that it has eight slices out of the entire 100% of the circle. This circle, its equal size, has 6 equal sized slices. This circle has 4 equal sized slices, and this has 2 equal sized slices. 1/2 is the reduced form. It's what happens when you simplify or express in lowest terms fractions. So 4/8 is the same as 3/6, is the same as 2/4, is the same as 1/2. They equal the exact same amount. You can see all equals 1/2 of the whole circle. We see that each picture illustrates half of a circle. The model that uses the fewest pieces is 1/2. We say that each of the other fractions reduces to 1/2. We can use our fraction manipulatives that we created or to reduce a given fraction by making an equivalent fraction or equivalent model that uses fewer pieces. So for example, if you have, in this case, if we were to say 4/8, you see there's 1, 2, 3, 4 is the same as 2/4 or 1/2. We could also look at it in a different way. Why doesn't 2/3, as in this one, this would be 1/3 right here, and this is also 1/3. Why do these 2/3 not reduce to 1/2? If you were to look at the reason, it's because this 1/2 is smaller than those 2/3. 2/3 would be 66 and 2/3% of a circle. 1/2 is 50% of a circle. So that's why it doesn't reduce. Use your fraction manipulatives to reduce 2/6. So we just did that. First, we use our manipulatives to form 2/6. And here's 2/6 right here. Say if we got those two right there. And if we want to have them, well, let's use these two here, the two at the top. I'm going to bring those two down and see what they form here. You can see they match up with that 1/3 there. So we can have that model to show that 2/6 reduces to 1/3. 2/6 will reduce to 1/3 using those manipulatives. 2/3 of a circle is what percent of a circle? Well, if 1/3 of a circle is 33 1/3%, all you need to do is multiply that by 2 or add it together. 33 plus 33 is 66. 2 is what 1 plus 1 is equal to, and you end up with 2/3. So this would be 66 2/3 for 2/3 of a circle. That's the percentage of that circle. Example 3, 2/6 of a circle is what percent of a circle? So 1/6 of a circle is 16 2/3%. And if you have 16 2/3 plus 16 2/3, you notice that it'll be 32 4/3 because 2 plus 2 equals 4. So in this case, when you look at 4/3, you have to recognize that that's the same as 1 1/3. So if you have 32 4/3 combined, that should end up being 33 1/3 because 32 plus the 1 is 33. And then you can't forget that you had the 1/3 there as well. So 33 1/3%. If you're looking at 2 1/6 Example 4, Rory lives 2.75 miles from school. He rode his bike from home to school and back to home. How far did Rory ride? This is an addition problem. So you've got 2 and 3/4 plus 2 and 3/4, and you're going to end up with 2 plus 2. You have to add the whole numbers first. So 2 plus 2 is 4. And then you add the fraction pieces. 3/4 plus 3/4 equals 6/4. That's an improper fraction. And if you were to take 6 divided by 4, you would get 4 will go into 6 one time. Subtract that, it'd be 2. And over that, because there 4 is there, this would be the same as 1.5. So if you've got 6/4 equals 1.5, you have to recognize that you had the 2 plus 2 there, which equals 4. You have 5.1/2 as the final answer. 2 and 3/4 plus 2 and 3/4 would equal 5.5 in the end when you add those. So you have to make sure the fraction part of the answer is reduced. So we add 1.5 to the whole number part of the answer to find Rory rode his bike 5.5 miles. Let's try another one here. Subtract 5 and 3/8 minus 1 1/8. So again, I just like to write these vertically. 5 and 3/8 minus 1 1/8. I can subtract the whole numbers here. I've got 4 in this case. 3 minus 1 is 2, and the denominator stays the same. But this part right here, this 2/8, needs to be reduced. That's the same as, if we go back, we could look at this one. If we have 2/8, that would be the same as this amount right here, 2/8. So 2/8 you can see is the same as 1/4 if you're using manipulatives. If you're not using manipulatives, maybe you can figure it out mathematically and recognize that 2/8, this piece is divisible by 2. This is also divisible by 2, which is technically like dividing by 1 whole in a sense, but you've got 1/4 in that case. So 2/8 is an equivalent fraction. It's reduced to 1/4. So it'd be 4 1/4 for the final answer. All right, let's try these. Use your fraction manipulatives. Those are your cutouts that you created to reduce these fractions, or you do it mathematically as well. But if you have your fraction manipulatives, you should be able to see what the biggest fraction piece will be equal to if you're looking at 2/8. All right, for letter A, you should have gotten 1/4. For letter B, go ahead and do that. 6/8. Using fraction manipulatives, you might recognize that both these are divisible by 2. If I divide them both by 2, I get 3 in the numerator and 4 in the denominator. This would be the reduced fraction of that. Letter C, go ahead and do 12.5% plus 12.5%. So I'd have to do 12.5 plus 12.5. And the answer is going to be in percent because both these are in percent. I'd add the fraction parts. I'd get 2 halves because 2 plus 2 in the numerators. Denominator stays the same. This would be 4 and 2, so it'd be 24 and 2/2%. Then you need to recognize that this 2/2 is the same as 1 whole, so it's like 24 plus 1, which equals 25%. So for letter C, this would be 25%. Go ahead and do letter D. So for letter D, you should have 16 2/3 plus 66 2/3, and those are both percentages. If I add the 2/3 together, I get 4/3 because 2 plus 2 is 4. And then 6 plus 6 is 12. Carry the 1. This would be 82 and 4/3. Then I need to recognize that this 4/3 is going to convert into 1 and 1/3. And I'd have to add that to the 82 that I have there. So that's 82 plus 1 makes 83, and then I need to keep that fraction portion of the mixed number. So it'd be 83 and 1/3% for the answer to that one. Letter E, 3 3/4 plus 2 3/4. So again, I'm going to write this vertically. And then I add the numerators together. That's 6/4. The denominator always stays the same when you're adding and subtracting fraction pieces. And then this would be 5. So now I need to recognize that this improper fraction needs to be converted into, if I forget what it is, I can just do 6 divided by 4. That's what it means. And 4 will go into 6 one time with 2 left over. 2 is the numerator and 4 is the denominator. And then that is the same as 1 1/2. So this 6/4 is actually equivalent to 1 1/2. And then I have 5 plus 1 1/2. In that case, that would be 6 1/2. And that's the final answer on that one. Letter F, 1 1/8 plus 2 7/8. So in this one, I'm going to write it vertically again, 1 1/8 plus 2 7/8. And 1 plus 7 makes 8, and the denominator stays the same, and 1 plus 2 is 3. I know that 8 over 8 is the same as 1, so it's simply 3 plus 1, which equals 4. So the answer to this is 4. Okay, go ahead and do letter G. That's 3 plus 2 2 2/3. So it'd be nothing in the fraction side, and then 5 here. That would be the end of that one. 5 2/3. Letter H. This one would be 3/4. And there's a whole number of 4, but there's no fraction portion of it. So that's simply just going to be 4 3/4. And then letter I, use words to write the addition problem in exercise F. So the addition problem in exercise F was 1 1/8 plus 2 7/8. So just for this one, I'll just type it out for you guys. That is 1 1/8 plus 2 7/8 equals 4. And that looks like, again, that looks like this. 1 1/8. Interesting how that happened. 1 1/8 plus 2 7/8 equals 4. That's what that one would be. All right, thanks for watching, and have a good night.